Hey robot makers, how you doing? Hope you're having a spooky Halloween so far. And yes, happy Halloween if you celebrate Halloween where you are. And if you're watching this on replay and you're thinking, what's going on? It's Halloween today. So I've got lots of spooky overlays that I can call upon with the click of a button. Just as my little spider that drops down there. And also I've got a little spooky ghost that can creep across. So let's just turn all those off. Okay, so do you want to know how to make a line-following robot, a Pacman or a ghost? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. So let's get to it, shall we? So yes, this is part 2 of our Halloween robots series. So last week we looked at how to build the robot, the ghost robot particularly, in Fusion 360. And all the different steps that were required to build that, and then create a 3D model that we could then send to a 3D printer and build. So I have my robots here. I've got my little ghost one ready to go onto our SMARS robot, and I have the Pacman one down there as well. Let me see if I can show you that one, if I can get the right camera. There we go, he's just on the floor there. That's a bit of a mess of a map, but we'll talk about that in a moment as well. Okay, so let's have a look what this show is all about. So we're going to have a look at the code today, how we can bring our robot to life with some line following code. And we actually covered this probably over a year ago when we did some of the SMARS series, Fun with SMARS, and we were looking at line following robots. So some SMARS robots, I'm just looking around to see if I can see the one that has the module on it. Some SMARS robots have this little line following module, which is like an add-on you can print out. And that enables you to sort of follow black and white lines round. Your robot follows the black and white line round wherever you've put that. So we're going to use the exact same code, and we're going to build that into our robot as well today. So we're going to have a recap on what we did last week. We're going to look at the line following code itself. We're going to have a go at loading it up onto a SMARS, and then we're going to demo out on a map and see what happens. Okay, let's get to it. So last week, yeah, like I said, we covered how to design the body of the robot, the ghost, in Fusion 360. The Pacman one is, to be honest, really simple. It's just an outline of a half a semicircle, and then you just revolve that round, and then I've just cut out a mouth and then designed some eyes as well, projected them through, and then just hollowed the thing out with a shell command. It's pretty simple, really. There are some mistakes in that I came across. One of them was just the height of all the sort of robotics that stacks up. So if I show you on this one here, there's sort of wires and things, and where the mouth is, it doesn't quite work, so I've had to sort of take that out. The robot works itself, it's not as neat as I would have liked it to be. And I had a lot of issues, which I'll show you in a minute on one of the slides. Lots of iterations of the ghost robot, just getting that skirt sort of shape to print out. Absolute nightmare. Don't know why. Well, I do know why, and we can get into what that is. So here we are, some of the fails that I came across. It's to do with bed adhesion. So for some reason, because where the sort of skirt piece sort of dips down and goes up, it had to build support material either side of that. And when it was printing out on the 3D printer, that bit kept coming away, and then it would just end up a holy mess, because I would tend to sort of leave it and come back to it and see how it went. And yeah, that was horrible. The Pacman one, I actually ran out of that type of colour, and I didn't buy in bulk, so I had he's got like a stripy bit you can probably just about see there. It's slightly different kind of tone of yellow than the rest of the robot, so that was a little bit annoying, but it's not the end of the world. But yes, that one ran out midway through the print, so I've got a version there that's the right colour, but it only prints out a little bit of it. And that one also had a few false starts as well. So you can see there, sometimes 3D printing is a bit of a nightmare. What I had to do as well with these is print them in sort of sections, because printing it all in one go, I would never guarantee that would work. So I thought if I slice it into sort of sections and then glue them together, it'll be fine. So I'm relying there that there's going to be absolutely no warpage, because when you try and glue together where it's sort of warped, you'll have a bit of a gap. So it's not too bad, actually. I think they've all printed out quite nicely, but there is sort of a noticeable line around the mid section, and similarly on there too. I could sand that out, could fill that in, spray it, and you'd never know. The other thing as well that was, in retrospect, the wrong thing to do, the build support material in Cura, the option I used was the sort of full support material. I didn't use the trees option. The trees option prints these really elegant kind of support structures just where they needed. Whereas the one that I had was like the fullest amount of support you can imagine. So where that mouth section is, I must have spent a good half a day just ripping out that section of support material, and it's not as clean as I'd have liked it to have been. So in retrospect, I'll probably design that a little bit differently, maybe even make it so that it can print without requiring any support. So if it's like 45 to 50 degrees, I think you can get away with, you don't need any support material. So there's a few learnings for me designing these, but overall they work really well. I'm quite pleased with the results. Okay, so that's the failures. So the goals of the code. So what I want to do is write some code that's going to take some readings from a line following module. And these line following modules are very, very cheap. See if I've got one to hand to show you. So I have got one just here. It's got this one stuck to the front of this robot. If I can just show you which way do I need to do it. There we go. So I think this is called a HW201. There you go, HW201 it says on the top there. I just sort of zoom in on that so you can just see there, HW-201. They're very cheap, and they simply have voltage in, ground, and then a signal to say what the depth, whether it's receiving a light or a dark signal. And you can either read that in as an analog read and get a number, I think between 1 and 1024, I think it is, or you can just do a digital read, is it on or is it off, and that's what I've gone for in this code, just to make it a lot easier. So the code is very simple. It's basically going to move our robot forwards, or turn it left, or turn it right. And for bonus points, if we have time today, have included on here a Bluetooth module, so it can send the data back via Bluetooth, and then we could do some interesting things with it. So for example, we could send that to a ROS node and read that in as some sensor data. We could do all kinds of things like that, and maybe send back through the Bluetooth commands to do something like move forward, what have you, rather than actually doing that on the device. So that's just a bit of a bonus. If we can get around to doing that today, we can look at that too. Okay, so the actual game board. We looked at this briefly last week, and I'd drawn it out in OmniGraffle, but I hadn't actually printed that out. So I have printed that. I have copies of that, as I said, behind me, which I think is that one there, printed out. I've not stuck them together yet, and we'll have a look at that in a moment too. Oops, so let's get back to there. If you want to download a copy of these PDFs, you can do. If you go to Buy Me a Coffee /Kevin McAleer /E/47094, you can find a copy there. If you just go to the Buy Me a Coffee site /my name, you can also navigate to that as an extra. So if you want to buy that, it's I think it's only £4. If you're already a member, you'll get that for free as well, just for being a member and supporting the show. So have a look at that, and it helps as well if you support the show. So if you like what I do and you want me to make more of these kinds of things, make sure you like this video, whether you're watching on YouTube, on Twitter, on Facebook or Twitch. Drop me a comment, tell me what kinds of subjects you're interested in. Do you like the Fusion 360 sides? Do you like the electronic sides? Do you like the coding? Do you like Arduino coding, MicroPython coding, Python coding? What kind of thing are you interested in there? And if you're watching on YouTube, make sure you hit that bell and make sure you've got all the notifications ticked as well, so you get notified when I go live with a new video. And I do go live with a video every single Sunday at 7 o'clock Greenwich Mean Time. We are in Greenwich Mean Time now. The clocks have gone back to that from British Summer Time. So we're back on regular Greenwich Mean Time now. And I also do a midweek video as well. And last week I did 2 midweek videos. I did one on how to install ROS on Docker, and then the Raspberry Pi organisation dropped a brand new product. So I did one on the Raspberry Pi 2 as well. So if you've not checked that out, have a look. That's quite a nice video, giving you a bit of a difference between the old Raspberry Pi 0, this is the original one, and the Raspberry Pi 02, which has quite a bit more to it. It's got a quad-core processor. Same amount of RAM though, frustratingly. So you can check out that video and see that. If you want to check me out on social media, I do have lots of social media accounts. So I'm on Twitter at KevsMac. I'm on Facebook. You probably find me Kev McAleer. And if you go to the Small Robots group, you can find me in there as well. I'm obviously on YouTube. So I think it's Kevin McAleer 28 on YouTube. On the World Wide Web, you can find me at smarsfan.com. I do have a mailing list now, so if you want to join the mailing list, the easiest way is to go to smarsfan.com/about/link_in_bio, and then you'll find all my social media links there too. I think I have got like a little underlay thing that pops up with all these on as well. And I'm also on Instagram as well. I think that's just Kevin McAleer or SmarsFan. I'm on both of them. So you can check me out on all those different places and follow me there as well for lots of extra media and whatnot. Okay, so next week I've got a really cool guest. I cannot wait for you to meet Liz Clark. You might have already watched some of her stuff or even read some of her stuff. So she's an author, she's written a book. She has lots of guides on Adafruit, on the learning system over there. And she has a YouTube channel. She's built so many cool things on there. So can't wait to introduce you guys if you've not already met Liz from Blitz City DIY. And we can have a really cool hangout and chat about robots and electronics and stuff next week. So if you have any questions that you want me to ask, if you can let me know in advance, I can sort of share those questions with Liz, and we can she'll know in advance the kind of things that people are asking there. So let me know in the comments of this video, either on Facebook or on YouTube, and or on Twitter, whichever you wish, and let me know what kind of questions you want to ask. So that's next week. Can't wait for that. So should we have a look at some code and do a bit of a demo? So before we do the code, let's have a little look at what we have going on. So let me get to my overhead camera. That's not the right camera. I want the overhead one. There we go. Okay, let me just adjust the lighting slightly on that so that we can see what's going on. Okay, so I want to have... It's my desk lamp, that one, isn't it? Oh, it says it's not responding. Okay, we'll just have to just flip it up like that. And then it'll adjust. There we go, that's better. Okay, so I've got a couple of Smars robots here. And what we do with this, the skirt piece, if I just pull this off for a second, I can show you how this works just on this little one. So this is just a shell of a Smars chassis. It's just got the motors in but no wiring or anything. And we have this, this section here which is designed to just fit into there, and then it holds into place. It's quite rigid, so the wheels are nice and free to sort of move around, but it does mean that we can have that ghost on top as well. So the thing with this is it's a little bit tight on there. There we go. So I'm going to put this back on the real one. Let's push that down a little bit. I do need to file these pieces out. I think when I printed it I didn't do enough tolerance, so I've got a little file that I've just been using to sort of file out these sections here and here. From the real one, which is just here, this one fits in quite nicely. So this is just my prototype one. And then I've got the line following module. I intended this originally to just sort of sit inside here. However, it needs to be, in reality, it needs to be really close to the paper, otherwise it can't make the reading. I've just got a piece of blue tack just sort of sat on there, and if I put that pretty close to the edge there, that should give us what we need. So let me just push that in there. Okay, and just make sure that's good, and then I'll just apply the power to this. So this has got the code already loaded, but we'll have a look at the code in a second. I just want to show you in principle what this is going to do. So let me just sit it on top of this one a second while I apply the power, because it will try and start moving right away. It's a bit of a pain to do. I've not actually attached a on-off switch. That would be the thing to do, really, wouldn't it? There we go. Right. So it's going a bit mental there. Let's just try and get this a bit closer to the page. There we go. What it's trying to do is just find the edge, but it's not quite close enough to the ground. Let's just move that down a bit. There we go. It's now following the line. So that little sensor there has got a transmitter and a receiver, and it's literally just bouncing the receiver around, and then as it goes just off the edge, it's then correcting it and just doing a right turn. So we can decide in our code whether we want it to turn right or turn left, and it'll just keep doing that forever. Now it's slightly off centre on this one, so ideally we would want this to be completely centred. Now on our actual ghost we can actually centre this. If I just show you this piece here, that piece of the skirt is pretty much dead center, so we could put that on dead center there. I'm just going to turn that off now. There we go. And we'll use the same robot actually. We'll use this one in a second, so I'll just remove that skirt piece and we'll just leave that sensor just dangling there. Okay. Yeah, let's leave it on the back. So you can see there it's just got the transmitter and the receiver. And that's pretty much all there is. There's just a single pin. It's going to pin number 5, I think this is. On here, it can go to any pin, to be honest. It doesn't have to be a particular one. And I've got the Bluetooth just going to pins 2 and 3. So you keep 0 and 1 free if you're using Bluetooth, just as a tip. Otherwise, when you're trying to upload code, you'll find you have some issues with that. Okay, so that's kind of demo of how the robot itself is actually going to work. Let me just load up the Arduino software and we can have a look at the code as well on there. So let me get this on screen, and let's make this a little bit larger. I do it like that. I think that's probably best, isn't it? Okay, so I've uploaded this code to GitHub. If you go to GitHub/Kevin McAleer/ line_follow_code, you'll find the repository where this code lives. And it's heavily based on the code that I wrote for lesson 7, and there was a video about that as well. So you can have a look at the code, the original code, or this one, and how we put that together. So the first thing we're going to do, we're going to have a variable that we call line sensor value, and that's going to store the current value of the line sensor. Now, because we're just using the digital read, it's either going to be a 0 or 1, true or false, but we could use that to store, if we were doing an analog read, the actual value that it's reading. But I found it didn't really help. You'd just have to have a threshold anyway to say, and it was around about 400, I think. But and it's based on how far away from the paper this is. Lighting conditions merely make a difference, and the solidness of the black, and I think the let me get this right, the reflectivity of the black as well. So if it's quite shiny, that you can get false readings, so it needs to be quite a nice matte black. So I found printing on a laser or a inkjet printer is more than good enough to get a solid. But if you try and mix the colours with this, or you don't have a totally solid line, you'll get weird readings. It might stop. So that's what the first one is. I've stored it as an integer. The next one is the line sensor pin. So the line sensor is on pin number 5 on my Arduino. So this is number 5 to represent that pin number. And then next up we have the motor A and motor B. Now, depending whether you have the official Arduino motor shield, or I use the Fujimoto ones, but other ones are available. Let me just show you on this one. This one is the official Arduino motor shield. You can see just on there, Arduino motor shield. And that means the pins that these things connect to, motor A and motor B, that sends the power to the motors in the direction, the speed that we choose, that's all governed by particular pins on the board. Oops, we need to go back to that one, don't we? And that code there. So it's either pin 12 or 13, and I think that's the same on the Fujimoto, which is the other motor shield that I would recommend. And then there is I've not got the buzzer switched on this one because we don't have a buzzer on this board. The Fujimoto one does have a buzzer, and that's on pin number 4. And then we have 2 for the motor A, motor B speed. So this is how fast they're turning. So we set them to be on or off, and then we set the speed, well, on or off, the direction, and then the speed which they travel at. So you can see on here the Fujimoto uses digital pin 10 and digital pin 11. For the official Arduino motor shield, it's it's pin 3 or pin 11. So that's the same, but pin 10 is actually pin 3 on this. So if you find that one wheel is only spinning round and the other one isn't, it's probably that the motor speed pin is incorrect. So just check for that. Then we have the wait in milliseconds between the motors turning on and turning off. So we're going to send a signal, say, switch these motors on for a period of time, and that period of time is called wait in milliseconds. So 10 milliseconds gives us a really granular, fine-grain, accurate reading from the from the line sensor, because it's going to read that. It's going to move forward a fraction for a tenth of well, 10 milliseconds, and then it's going to stop, and it's going to take another reading and then move forward. It'll look continuous as it just did then, but that's what's going on there. If we find that this is too slow, we could change that to 100 or 1000, but we might overrun the page because we've moved too far before we take the next reading. So that's what we use to sort of tweak the accuracy. We've got a block of code there that's talking about movement of code. So if you want to know about how to move a SMARS forward, backwards, left and right, you can look at those different lessons. I think I've moved them from play. I think they're now under learn, but I think it might still redirect you to the right place there. But anyway, we have the code, so let's read through this. So this is the forward code. So if we want to move the robot forward, we use the forward. So void just means it doesn't return any values. And then in between these squiggly brackets here, we've got this block of code. So we're going to write out to our serial, which is the cable that we're going to be connecting to, this cable here. If we want to use Bluetooth, this is where we would change this to like my serial, and we would have a different serial, a serial 2, which talks to pins 2 and 3, and we can try that in a moment. We can then do digital writes to motors A and B, and we're going to send low to one motor and high to the other. And that's because on our robot, our motors are sort of diagonally opposite each other, there and there. And one is turning in one direction and the other is turning the other direction to make them go forward. So if you think this one is rotating this direction, this one is rotating in that direction. If you turn them both so they were both facing the same way, they would look actually turning in opposite directions. So that's why we have to do high and low. And it also depends on the shield, which way round you plug in the black and the red cable. So if you get them the wrong way round, when you go forwards, it might send it backwards. So you can either change it in the code or you can just turn your wires around. I found that that works fine. We're then going to set the motor speed. So this is how fast the motors are turning round. So 255 is the full speed. So that's kind of 100%. If you did half that value, if you did like 128, that would be 50% of the speed, and 64 would be a quarter, and so on. We then wait in milliseconds, so then 10 milliseconds wait, and then we say stop the motors. Now, because this all happens so fast, it looks continuous. The motors are actually still turning slightly when they come to a stop. And that's it. That's how we move the robot forward. So to move it backwards, it's actually just the opposite. So where we did low and high, we just do high and low. We just make the motors turn in the opposite direction. The same code again, we do an analog write to the motor speed A, motor speed B pins, and we say 255 is the full speed to those. We wait again, that waited milliseconds, the same amount of time, and then we do an analog write to motor A, motor B speed to 0 to say stop the motors. So that's how we move the robot backwards. So to turn it right, we again do a digital write. All that serial.println is doing, by the way, is just writing out to the serial monitor. So if I just click on that and go to Tools and Serial Monitor, let's see if this will actually load up. We've not got a robot plugged in, so let's just plug in a robot to this to actually use. Let me just plug this in. I will start trying to move away as I do this. So let's just hold it up while we do this for a second. So I'm going to plug this in. And at the moment it's trying to just turn right, I think it's trying to do. So if I open up the serial monitor, so let's try that. Tools and Serial Monitor. Yep, I've got a serial monitor. Let me just drag this into the screen so we can see what's going on. So it's saying there turn right, turn right, turn right, and it's saying 0. The 0 is what it's actually reading at the moment from the line sensor. If I move that line sensor over the black part of the page, we should get a 1. So that's the black part of the page. If I move it to the white part of the page, it's 0. So 1, and it's moving forwards, and on the white bit it says turning right. So those messages, that's what this serial.println is printing out. Let me just stop that now. So serial.println just sends a message to that serial console. So that's how we turn right. We just make motor A and motor B high, so both of them are going in the same direction, but that actually has the effect of just turning the robot that way, so it sort of turns to the right. So the track spin in opposite directions, and that has the effect of turning it to the right. And we don't say how far to turn as an angle, we just say turn to the right for 10 milliseconds. We just do that wait for 10 milliseconds. The motor speed's 255 again, so full speed on both of the motors, wait for 10 milliseconds and then stop. And then to turn left is the exact opposite, so instead of them both being high, we then do digital rights to motors A and B and make them go left. So turning them both low makes them go in the opposite direction, so they both spin in the same way, which has the effect of turning the robot the other way. And then again we wait 10 milliseconds delay and then do an analog right to the motors to stop them. And that's it, that's how we turn our robot. So we're actually not going to use backwards, we're just going to use forwards and turn right for our code. The next block will read in from our line sensor, and all we need to do with that is just read a digital read from the pin, which is pin number 5, and then return that value to whatever is calling it. So you can see here when we have a void that says it doesn't return a value. This one does return a value, so we're returning an integer value. So we're reading in from the digital read from the line sensor pin, and that's going to return a 0 or a 1, and we return that to whichever function is calling it. So that'll be in our main loop down here. And then the next block of code here is the setup code. So when our code very first launches, it's going to run this once and then go to the main loop. So in here it doesn't return a value, it's a void. It does a serial.begin, and then we pass the baud rate. So this is the speed at which we're communicating over the serial cable. So that's 9600 baud. If you want to know more about that, I have done some videos on serial programming. So I think it's on the same series as this line following one. So if you look back on my YouTube channel, you should be able to find that about baud rates. Then we have set the Arduino pin to outputs. So pins can be either inputs or outputs, and we need to tell the compiler whether we're going to be reading a value or whether we're going to writing a value to that particular pin. So we say pin mode, and you can see that's in orange, meaning it's a reserve word. Motor A is an output, motor B is an output, and line sensor pin is an input. So that's going to set those variables up to be those particular types. Okay, so we are now going to get into the main loop of code, and this is it. It's very, very simple to do line following. So we're going to read in a value from our line sensor, which is connected to that line sensor pin number 5. We're going to say line sensor value, which is our variable we set up at the very top. We're going to make that equal whatever the read line sensor function returns. So that function there is going to do a digital read from line sensor pin number 5 as an integer. It's then going to pass that back, and then line sensor value is going to hold that value. We can then say if line sensor value equals 1, and it's double equals because we're doing a comparison rather than setting the value. So it's comparative operator. If that's 1, then move the robot forward by just using that forward function that we defined up here, which is just there. So it's going to run through this line of code. And then it's going to say serial.println line sensor value. So that was what that 0 or 1, that's how that was being printed out. So if it's not 1, it's going to be 0. So we can simply just use the else. So if it's not 1, otherwise turn right. So it's either going to move forwards or it's going to turn right. And what we could do, we could print out a command there that says turning left, moving forward, and so on. It does just make our console output a bit difficult to read because it sort of flies past and you've got all these messages. So one technique I tend to use for this is if I've got lots of different things going on, I'll have one print line, and that contains all the different things that are going on, all the different states. So as it sort of scrolls up, you can just look to see all the different columns of information. And then the last thing we do is we read in again the line sensor value, take another read in, and then just print that out. A bit redundant that we could actually remove that code and there'd be no ill effect to that. We just wouldn't know what the value is. We are actually printing it out there. So the fact that after all this code is run, it's going to do that again, we could actually just comment that out. So if I press the Alt and / key, I can toggle making this a comment or not. And you can see it's got the double slash there for a comment, and it's sort of gone grey as well. So if we press this button here to verify our code, it's going to compile the code and see if it's valid. Shouldn't be any problems in there. So we can see it's done compiling, and it's a very small program this. So I can connect this up to our robot. Let's do that. And we can just use the upload command, and it will now upload that code. So if I go over to here and I change my bench cam, let's see if I can change that bench cam to be the correct one. So it needs to be that one there. Let's just change that to, is it that one? No, is it that one? Yes, there we go. So I'll just do that again so you can see on here. If I just bring the line following code down, I press that, momentarily it will stop running the code on the robot and you'll just see that wheel stop spinning round. There we go. That means it's uploading the code, and now it's finished uploading the code. So if I put this down here again, let's put this on here. Let's see if we can get this to work. I just need to plug the power in from the 9-volt battery. It is trying to power the motor shield via the USB cable, but it's limiting the amount of voltage it's going through that, so it won't actually work very well. So let's try that. Let's see if this will... Right, let's get this really close to the paper. See if I think it's getting a bit stuck there. Let me just move that back a bit. It's going a bit mad there, isn't it? So I'm just going to check that it's actually, it's trying to turn right at the moment, which is the correct behaviour. What I need it to do is take a reading from here. There we go. That's reading correctly. There we go. Reboot that. That's behaving a bit strangely there. There we go. So it is trying to grab. Let's just pull out for a second. It is behaving a bit strangely here, and I think it's just that the power wasn't being connected properly. So I'm just going to screw this back in properly on here. It's always a bit fiddly to do because the wheels try and grab whatever it's leaning on. There we go. That's it. Yep, that's working properly. So what I need to do now is just get that sensor so that when it's flat on the floor, it's just touching. Let's try that. Let's try that now. And it's also getting a little bit stuck on the paper, I think, as well. It's not a very good structure for it to actually be... Yeah, so it is working. It's just a little bit too close to the card. And now it can't read it because it's not quite far enough. So there is actually on here a little pot that you can turn. So if I just get this into view, there's this little blue pot here. And if I turn that, I can turn the sensitivity sort of up or down. And that's one way that we can tweak this as well. This isn't going to work if it's not quite reading it properly. Just try and adjust this as we go. It's a bit noisy, so there we go. That might be a bit better. Oh, that's too much. It's not reading it now when it comes off. There we go. That took a little bit of getting going. Let's go back to our combi view. There we go. And that's now working properly. So we can go to our proper overhead view there and see that that's now working. Cool. So hey Alex, Alex is our new moderator. She's just joined. She's in Sheffield at the moment, so she's not in the same room as me at the moment in Bolton, which is where I am. That sensor's actually come loose now. Anything could happen on there now. The actual blue tack isn't holding that in place anymore, so that could just go and fly off the table at any moment. So I'm just going to turn it off for a second, and then let's try and get the Bluetooth working. Right, so let's just have a look at our code and see if we can get this Bluetooth working. So it's just a matter of going through, and wherever we want to send or receive a value, we can simply just read that from the Bluetooth. So let's go back to our Arduino, and at the very top, let's define a new, actually we can do it in our setup code. So let's just find setup, which is there. So where we've got serial.begin, we can do my serial, and we can say, actually I think we need to define that a bit further up. Let's just go back to the top, and we'll do it under here. And the type of this is serial, so I think it's serial, and then my serial, and then I think that's all we need to do. It'll tell me if that's wrong. Let me just compile that and see if that works. Right, so do we need to bring that in as a library? I think we need to bring that in as a library. So if I go to include library, and it's the serial, software serial, there we go. So let's try that again. Is that going to work? Serial does not name a type. Is it a software serial, is it? There we go, let's try that. Yep, that's the one. So we've now got this thing called my serial, so we can go back down to our setup, and we can add that in next to that one. So where we've got the serial, we can have my serial.begin, and again, let's do 9600. We do need to go to the top though and tell it what pins it's going to use. So I think we just do pins 2 and 3. I think that's how we do it. Let's just compile that. If we get stuck on this, we can always just go to the Arduino software documentation and have a look what's going on there. I think if we just right click on that, you can do like find reference. In Visual Studio, I think you can actually pull up the proper documentation just by right clicking and finding the help. But we don't need that today. We can just go back down here. So that's going to set it up as being 9600. And then whenever we output a value such as this serial print line, we can do the same with my serial.print line, like so. And that will output everything that's been outputted across to our serial monitor via Bluetooth as well. Okay, so that's the loop. So we can do that in these ones as well. So yeah, where we've got like turning left, we can also do like my serial print line, turn left, oops, like so. Let's grab that, and we'll do the same on all the other bits and pieces. So turning right, we don't actually use turning left in this code. Now what I do like in Visual Studio is if you don't use a block of code, it will actually grey out that block of code to indicate that that's not used anywhere. But the Arduino IDE isn't as smart as that. I have tried to get the new Arduino backwards. There's like a beta version, version 2. I can't get that to work. Whenever I try and load that up, it just sort of hangs and doesn't do anything. So I've no idea what I'm doing wrong there, but it is beta version. Okay, finally we've got forwards there. I've not figured out how we're going to connect to this and read the values yet, but we can figure that out in a minute. Okay, so I think that is it. We could also just do, where we do the begin in the setup, we could just have a little message that pops up saying, oops, undo that, redo that. Let's press the wrong button, then it undid everything. There we go. So where we got that there, we could have a serial, sorry, my serial dot write the print line. And we can say online, something like that. Okay, let's compile that and see if I've made any mistakes. If not, we can say good to go. We can upload that to our robot. It should behave exactly the same. It just means that it's now outputting those messages over that Bluetooth. So let's just upload that code. Okay. Right. So I'll leave that doing nothing particular at the moment. I've not put any power to that, so it's just kind of doing that at the moment. But in fact, yeah, that's fine. So what I can do now, if I go to my Bluetooth settings, let's see if I can find this thing. So we can talk about postbag. That's just reminded me that Lego thing. Where's the I'll find that in a minute. Remind me about that in a second. So I need to pair that. That's what I'm trying to do. I'll do it from my phone actually. That's probably the easiest way. So I've got on here that Dabble app, and I'm just going to bring that in as a terminal, and I'll show you this in a second. If I just press the connect button, I can then scroll down and try and find this device. I think it's that one there. Let's see. And let me see what speed this is currently running at. So I can see that it's flashing as if it is, I'm not sure that is connected actually, disconnected. Let's try connecting to another one. I should have tried this bit out. I did say it was for bonus points, but this is like live coding. So I'm trying to find the Bluetooth device on my phone to connect to. And once I've found it, we should then be able to see that data coming through on a different device. That's all I want to see. So let me just press that one again. I'm going to apply the proper power to it so it's not running off. I'll try and run away when I do this. Let me just try that one more time. I'll just screw in the... I need to put an on-off switch on this robot so I can just easily switch it on and off. Oh, otherwise, every time I want to disconnect the power, I've got to undo that little terminal. And every time I try and plug it in, it tries to run away, and that means it isn't fastening properly. Right. That's not a very good connection either. Oh, good grief. Okay, let's just try this one more time. So I'm just going to try and push that cable into there. That can behave. Right. Let's just stick that on there. I don't really care what it's doing other than sending Bluetooth out. Okay, let's try this again. So I'm going to open up the terminal. I'm going to connect to that device, which is that one there. Okay, and I would expect to start seeing stuff come through there. So have I got everything correct? I can't see how you can set the baud rate on that. That's what I'm looking for. Let's try, instead of terminal, so let's try something else instead. Kind of. So I did connect to it. The reason I can see I've connected to it is the Bluetooth module stops doing its flash when I connect to it. So when I press that connect button there and I find the device, and it just pops up. If I press connect on there, we're now getting a solid light. So I don't know if you can see on there that light's gone solid, but I'm actually not getting any data coming through there. So that's probably because this app is doing something to that data and isn't showing it properly. Which is a bit annoying. I don't know if it's the right baud rate, and I can't see how to set the baud rate on this. I bet it's at like a standard baud rate. So we could fiddle about with that. Let's not do that. Let's go to the next bit. We'll be there all night with that, actually. We can leave that going, actually. Let's just keep that going there. And what we'll do now, so I've got my Ghost 3D printed Ghost robot head. And what we're going to do is we're going to slot this into place. So I do just need to move that sensor for a second. And it's going to slot into that little track just there. So if I just do that, I have already prepared this one, so it should go in quite easily, like so. And then all we then need to do is just put this sensor into place. So let's stick it on the outside so that we can see what's going on. Could actually make it go through the mouth. Let's see if we can get it to go through the mouth. Now the only mistake I've made with this is I've put the lid on and I've glued that into place, so it's not very easy to sort of move things about now within that. I can stick my finger through there though. That can help. This is where it really could do with an on-off button as well. Tell you what, let's take this off again and let's just push that sensor through before. Let's stick that sensor through there first. There we go. That's better. And now we can put that into place. Right. Okay. Now we're cooking. So what we need to do now is just push this into place right in front of our Ghost. Like so. Let's see if that's going to work. There we go. There we go. Okie doke. So it's now following the line with its Ghost robot head on. And it is sending out data via Bluetooth. I'm just not able to read that in by anything that I have to hand. It's a lot easier to do this actually on the Raspberry Pi. So if you go with a Raspberry Pi, you connect using the Bluetooth Connect in the user interface. You can then just go to like the terminal and go to the devices /dev in the console. You'll find something like it's not called USB. What's it called? It's like TTY, and then it will have the name of the Bluetooth device that it's using, and then you can just read data from it like it's a file. So that thing's just going to keep on going round until I pull the power on it. Right, so what I'm going to try and do now is I'm going to put it on this maze. Now this maze isn't all joined up, so it'll probably just go round in circles, but let's try. Let's just put it down there and see what happens, shall we? So it's probably just going to get stuck on that one line and just follow its way round. It's found a different line to go on this time, and then it's going to find that one, it's going to follow that line. So you get the idea. So one of the things I think I need to improve upon this map, so if you're buying this map and you're downloading it, I will give you a new version that's updated, but the angles on it in the corners are right angles, and that's not great for line following. There needs to be a much more rounded line. So the new version that I'm just working on for this has sort of sweeping lines rather than these sort of 90-degree angles. The top edge has a nice round bit, and when it's following that, you can see there what it's just done there. It worked much better. It sort of gracefully turned round, but where it's got a right angle, it will just tend to go straight through or get confused and just basically just spin round in circles. The black lines are also quite thick, so you can see that it found a bit of a line, went across the line rather than following it, so maybe the lines need to be a bit thinner as well. The Pacman one, that is also a robot. I can grab that one. So we have this one here. And what I was saying about the mouth section sort of sits over here, which means we can't have the normal robot in that kind of configuration. This is too tall for that, so I've had to just sort of shove that to one side. And the other thing that I did in this version of the robot was have the line sensing module just coming through there, but that, if you think this is where the floor is, it's about 1 centimetre, 3/4 of an inch, whatever, away from the ground plane, so it isn't close enough. So although that's quite nicely engineered to sit in there, it needs to be much further through. So what I'll need to do is just push that through further. This has also got the Bluetooth module on there as well, and it's nicely connected to the base of that. And then I'll just need to glue that top piece on, and this will work exactly the same. So you just sort of push this into the bottom of the Pacman. Let me just grab that so you can have a closer look. So this is the Pacman piece. So what I was saying is that piece will have to sort of sit up there, like so. Let's get my fingers in a knot with the wires there. And then this piece will sort of sit over the top, like so. Like so. And then I basically just glue those two sections together, and then that robot can just sort of fit into place there. Now what I was saying about the I don't know if you can see there, the support material that was supporting this piece whilst it was printing, you can see it looks a little bit messy, it looks like braille. And there are two black eye sections that you can print out as well. You can't really see on this camera, but that section there is actually a different shade. This section here is a different shade of yellow than that piece and the top piece. But from a distance, you can't tell. It looks fine. How cool is that? We have a Pacman robot. Quite impressed with that. Cool. I'm just going to stop that one from behind me because that's going to drive me nuts. Ghost robot. The other cool thing with this that you can't really see from here is that this is glow in the dark. So if I've got a torch, let's see if I can. I'm just going to stop that from going because that will drive you nuts, that sound. Right, so we just need to take the ghost hat off. And let's just disconnect the power. Oh, it's a bit mental this when they're all just flying off. There we go. Right, let's just take off that sensor, put it back through his mouth hole. Purely by accident did I design that mouth hole perfectly to fit that. Right, so if I just get a torch, if I've got a bright light next to me actually, or even this light here, I don't know if we'll be able to see that this actually glows in the dark. I turn that off now, does it? No, it's not dark enough for you to see that. Maybe if I put my phone torch on it for a second, we might be able to see a bit of greenness. Let's see if we can get it to do that. Yeah, there's a little bit there. I just cover my face up. Yeah, it's not very strong, but there is like, I can see that there's like a bit of a green glow there. Kind of looks like the greenness behind me, but then it dies off quite quickly. So I'm not sure, maybe you would have to have like a, you know, a light from within it for a while. I don't know how long it takes to sort of charge up these illuminated things, or whether they're just not very good. But yeah. So I've actually got, let's turn off the torch there. I've actually got 3 different colours of this. I'm looking at my supply of 3D print filament there. I've got blue, I've got red, and I've got this dark green. So yes, that was quite fun. It doesn't seem to be the best kind of PLA. That's one of the issues I've had. Gets a bit stringy, and yeah, this is one that a piece broke off. So okay, so I hope you enjoyed that. I'm going to go to the question and answer session now. I'm going to do something differently from now on. I'm going to cut these sections out when I do the replay. So if you're watching this on replay on YouTube, this is where the video will end. So thank you for watching. And for people who are watching live now, we're going to continue with the question and answer session. So you're missing out on this if you watch the replay and you don't join the live stream. So for those people who are watching on replay, I shall see you next time, and thank you for watching.